Time for this nation to take a clearly leading role in space achievement, which in many ways may hold the key to our future on Earth.
It's one small step for man, one giant leap for mankind.
Today is a day for mourning and remembering. Nancy and I are pained to the core by the tragedy of the Shuttle Challenger.
The following program may contain coarse language, adult themes, and bad attempts at humor. Listener discretion is advised.
What is President Trump's goal? What is his vision? He wants to put an American flag on Mars.
Houston, Tranquility Base here. The Eagle has landed.
I am your host, J.E. Double F, also known as A Cosmic Bard over on X/Twitter. And this is the Lost Wanderer podcast for August 10th, 2025. Happy Sunday evening and welcome aboard the Serenade. Now, if you grew up with star charts taped to your wall, Jim Lovell was one of the quiet voices in your head that taught you how to read them, not with poetry or slogans, but with the steady cadence of a naval aviator who knew that in the dark, checklists are a form of love. On August 7th, 2025, Lovell died at the age of 97 in Lake Forest, Illinois. The country lost a hero. Spaceflight lost one of its best navigators, and the rest of us lost the calm between the beeps. Lovell's road to legend was flown, not declared. Selected in 1962 as part of NASA's New Nine, he joined a cohort that would take America from rendezvous practice to the moon itself. He would end up flying 4 missions: Gemini 7, Gemini 12, Apollo 8, and Apollo 13, logging roughly 715 hours in space, a record in his era until Skylab stretched the yardstick. Gemini 7 in December 1965 was a marathon, 14 cramped days with Frank Borman to prove humans could endure the length of lunar mission. Gemini 12 in November 66 paired Lovell with Buzz Aldrin and helped rewrite how we spacewalk systematically with handholds and foot restraints instead of just brute force. Those flights built the muscle memory for what came next. Then came Apollo 8 in December 68, the first crewed voyage to lunar orbit. With Frank Borman and Bill Anders, Lovell became one of the first 3 humans to circle basically another world. I know you can get technical, but it is what it is. They read from Genesis on Christmas Eve. Anders photographed Earthrise, and Lovell, the command module pilot, kept the numbers tight while the whole planet stared back at himself from 240,000 miles away. That mission didn't plant flags, it planted perspective. But the story that engraved his name in the history didn't begin with triumph. It began kind of with a bang. Apollo 13 launched on April 11th, 1970, and 3 days later, an oxygen tank exploded, crippling the ship. The line most people remember, "Houston, we have a problem," was Lovell's voice, level and clear, reporting catastrophe. What followed was an unprecedented exercise in real-time problem solving. Engineers on the ground and astronauts in space became one crew, jury-rigging CO2 scrubbers, conserving power, and plotting a trajectory that would slingshot the crippled spacecraft around the moon and back home. No one on that mission set foot on the lunar surface, but survival, well, let's face it, was its own kind of victory. Lovell never flew again after Apollo 13. retiring from NASA and the Navy in 1973. But the end of one mission simply began another. He took on executive roles in the industry, first with Centel Corporation and Telecommunications, then as president of Fisk Telephone Systems, and later in senior leadership at Centel's parent company. The cool-headed systems thinking that kept Apollo 13 alive turned out to be just as valuable in boardrooms as in space capsules. But he didn't stay clustered into corporate life. He was a tireless public speaker, crossing the country to share not just the war stories from his flights, but the lessons beneath them. The value of preparation, the power of teamwork, and the grace of steady hands under pressure. His memoir, Lost Moon, co-authored with Jeffrey Kluger, became the blueprint for Ron Howard's Apollo 13, where Tom Hanks would end up portraying him with the same quiet steadiness. Now, back home in Illinois, Lovell also embraced his community. He and his family opened Lovell's of Lake Forest, a restaurant that sort of doubled as a space history gallery. Diners could eat prime rib beneath the berry maps and memorabilia that had flown to the moon. The upstairs bar displayed a model of the Apollo 13 command module, and the man himself would sometimes stop by to greet guests, telling stories that didn't make it to the movie. Even in his later years, he remained a go-to voice whenever humanity's eyes turned skyward, whether commenting on shuttle flights, the return of lunar planning, or the rise of commercial spaceflight. He saw Artemis announced, Orion tested, and a new generation of astronauts training for the same journey he once made. And now, with his passing, a page turns. The roll call of those who have flown to the moon grows shorter. And with it, a first-hand chapter of history recedes into memory. So tonight, as you maybe step outside and look up at the moon in its near full glory, remember that Jim Lovell's hands once traced every crater in Mare from just 60 nautical miles away. He didn't get a chance to walk on its surface, but he navigated the long road there and navigated the longer road back. And in doing so, he showed us that heroism isn't about planting the flag. It's about finding the way home when your map has been burned. And on your screen again is something I've done for the Apollo here is people have flown to or to on the moon. There's not many in there with the green status of living legend anymore. We really are losing the last of some great heroes. It's kind of sad when you think about it. But from the Saturn V's fire that lit the path to the moon, we turn to a new kind of rocket flame, one aimed not at lunar seas of tranquility, but at the rusty plains of Mars. And this time, the boarding pass, well, it belongs to Italy. There is a new passenger on the manifest for humanity's trip to Mars, and it isn't another billionaire with a selfie stick. The Italian Space Agency has signed a deal with SpaceX to send scientific payloads aboard future Starship missions to the Red Planet. Now, this isn't a ride-along for, a little itty-bitty single CubeSat. It's a package of experiments designed to test technologies, biology, and instruments in the very environment we've been chasing for decades. This will mark the first commercial Mars flight agreement for Starship, and the plan is bold. Rather than waiting for NASA or ESA to fly a flagship mission, Italy's experiments will hitch a ride on the privately operated spacecraft, aiming hopefully for the end of the 2020s when orbital mechanics line up for the next optimal Earth-Mars transfer. The specifics are still a little bit under wraps, but the science wish list includes testing life support systems, measuring the Martian atmosphere's dust and radiation profile, and assessing how electronics handle months of deep space exposure. If it works, this will set a precedent. Mars science doesn't have to wait for decade-long government timelines. You could see universities, private labs, and even smaller national agencies booking cargo space to run their own experiments. And it's a bit of a seismic shift. Mars research moving from rare flagship missions to something approaching a more regular service. Of course, there's a big if in the equation. Well, let's face it, Starship hasn't flown beyond Earth orbit, and Mars-bound flights will demand an entirely new level of reliability in orbit refueling and precision entry into Martian atmosphere. But if the same vehicle that's been designed to ferry cargo to Earth orbit and the moon can also make the crossing to Mars, then multi-planetary stops quits kind of being a slogan and will start being a shipping schedule. Somewhere in a lab in Rome, there's probably a small metal container no bigger than a bread box that will one day look out a viewport and see the planet Mars looming larger by the minute. And when that happens, it won't just be a win for Italy or SpaceX. It will be another step toward the day when Mars may even have its own customs office, and your experiments don't have to clear it by radio. But before we can talk about the first Italian experiment landing on Mars, well, we have to bring some current travelers home. And their runway is the curve of the Earth itself. After 184 days orbiting at 17,500 miles per hour, the 4 astronauts of SpaceX's Crew 10 mission have come back to the only home they've ever known, even if it now looks a little smaller from their point of view. The Crew Dragon's capsule undocked from the ISS and began its long, precise ballet of burns and re-entry targeting, culminating in a splashdown off the coast of Florida. This mission was more than just a half year in microgravity. Crew 10's roster, Commander Matthew Dominic, pilot Michael Barrett, and mission specialist Jeanette Epps and Alexander Grimbenkin juggled over 250 science experiments, maintenance on the ISS's aging modules, and multiple spacewalks. They monitored how the human body changes in low gravity, tested autonomous docking software, and worked on power systems upgrades that kept the station alive as it approaches its 3rd decade in service. Now, re-entry always comes with a little bit of a dose of drama. As Dragon hit the upper atmosphere, its heat shield faced temperatures hotter than molten rock. The parachutes were deployed in sequence, slowing it from hundreds of miles per hour to a gentle bobbing in the Atlantic. Recovery crews were on site within minutes, pulling the spacecraft onto the deck and beginning the post-flight medical checks. Now, this isn't done because the astronauts were in danger, but because half a year without gravity kind of rewires your sense of balance and muscle control. Oh, for the astronauts, this return isn't just about science data and spacecraft checkout. It's about hearing waves instead of fans, smelling salt air instead of recycled oxygen, and feeling the press of their own weight once more. But it's also a bit of a reminder. For all our talk and dreams of Mars and Moon's missions, Earth is still currently the only planet with a welcome mat. But that said, not everyone is happy with what SpaceX is doing. I know. Shocker. And while we're big fans of their work here on the show, science has a way of pointing out where even your favorite player may be stepping out of bounds. Astronomers have been sifting through a staggering archive, 76 million radio telescope images to hunt for signals from the distant universe. But in a perhaps surprising twist, some of these images are full of radio interference and frequencies where no transmissions are supposed to exist. Researchers are saying the patterns are likely, stress that word, likely from SpaceX's Starlink satellites, though they can't really confirm it with absolute certainty as of yet. And it's worth noting that other satellite constellations have been caught possibly causing similar problems. But of course, they're only going to mention SpaceX because of Elon. But that said, we do love science here. So the study comes from researchers analyzing data from the Low Frequency Array, or LOFAR, a network of antennas spread across Europe that listens to the universe in long radio waves. These frequencies are meant to be quiet zones where terrestrial transmitters are regulated or outright banned to protect astronomical observations. Yet the data shows faint, unintended emissions that seem to line up with Starlink's orbits. Now, the good news is these aren't deliberate broadcasts. They're a byproduct of electronics, some solar panel wiring, and onboard systems interacting with the space environment. The bad news is that as Starlink and other satellite constellations multiply, the interference can add up, making it harder to detect faint cosmic signals. Kind of like, the whisper of hydrogen from the early universe, or maybe even the signatures of distant pulsars. Now, SpaceX has already been in conversation with astronomers on just how to reduce optical brightness from its satellites. They've tested darker coatings and sunshades and implemented some of these. Now, the focus may shift to electrical quieting, maybe more shielding and design tweaks that can suppress these unintended emissions. That said, it is a fixable problem, but one that will require cooperation between commercial operators and the scientific community. Astronomy has always been about looking outward, but keeping the sky and the airwaves clean enough to hear the universe means sometimes turning our attention back toward what we've launched into it. And if history is any guide, when engineers and scientists sit at the same table, well, as Jim Lovell in Apollo 13 proves, solutions tend to follow. And speaking of SpaceX and science trying to work together, nothing says cooperation quite like strapping a container of disease-causing bacteria to a rocket and shooting it into orbit. But hey, don't worry, unlike that fun stuff in China, this one, come to think of it, that fun stuff in China might have been. Anyway, this one is on purpose. If you've ever wished you could just launch your problems into space, NASA and SpaceX have done you one better. They've launched your problems on board. A recent resupply mission to the ISS was a carefully contained batch of disease-causing bacteria found for one of the most unusual medical experiments in orbit. Now, the goal isn't to give astronauts a very bad day. It's to study how bacteria behave in microgravity. Decades of spaceflight research have shown that certain microbes can change their growth rates, virulence, and even genetic expression when gravity isn't around to pull on them. In some cases, bacteria become more aggressive or resistant to antibiotics in space, which is exactly the kind of thing you'd want to understand before, sending humans on multi-year voyages to Mars. Now, the experiment will monitor these microbes in sealed, triple-contained lab modules aboard the ISS. Astronauts will conduct controlled growth and sampling while ground teams analyze how the bacteria's biology shifts compared to identical samples being kept on Earth. The findings could lead to better infection control strategies for future crews, and even offer insights into how bacteria adapt to new environments here on the ground. Of course, there is a bit of certain mad scientist quality to deliberately sending germs into orbit, but in the long run, this may actually be, quite a good defensive move. The more we know about how pathogens adapt to space, the better we can protect both astronauts and planetary environments from microbial surprises. So the next time you hear about, a rocket launch, remember, It might not just be carrying satellites or, astronauts. Might be carrying teeny, microscopic hitchhikers with maybe a lot to teach us. But while we're on this subject of astronaut health in orbit, we do have some news that's a little less uh-oh and a lot more, oh, okay. For living on the ISS means adapting to a world really without up or down. But it turns out your cardiovascular system may be better adapting at it than we previously thought. A new study has found the astronauts' arteries remain healthy even after long duration space flights, challenging earlier concerns that months in microgravity could accelerate arterial stiffening or cardiovascular disease. Researchers have long known that space travel does, in fact, change the human body. Fluid shifts toward the head, muscle atrophy without constant use, and bones lose density without the daily stress of gravity. Previous studies hinted that arteries, the vessels that carry that oxygen rich blood from the heart, might stiffen in microgravity, potentially raising some very bad long term cardiovascular risk. But this latest research tracked astronauts before, during, and after extended missions using ultrasound scans and other diagnostics. And the results, while there are temporary changes in the blood flow and vessel diameter during flight, astronauts' arteries generally return to their pre flight condition within weeks of coming home. There's no signs of accelerated vascular aging being detected. Now, this is good news for future exploration. It suggests that with regular exercise, proper diet, and careful health monitoring, the human cardiovascular system can handle the months and maybe even years of travel needed for missions to the moon, Mars, or beyond. It also underscores the value that has been the ISS as a long term human health lab, where we can learn not just how to survive in space, but maybe, just maybe, how to thrive there. So the next time you may picture an astronaut floating in the station's modules, remember their heart is still strong, their arteries are still supple, and, well, at least for now, the vacuum of space hasn't found a way to age their circulatory system faster than the Earth can. Now, as weird as this may sound, not every astronaut dreams of staying aboard the ISS. Some, well, they're already looking past it towards worlds where up and down, well, means something again. For some astronauts, arriving at the ISS is the pinnacle of a career. For others, it's a step on the way to somewhere else. And that's exactly how one newly arrived crew member feels, openly sharing that while they're thrilled to be part of an ISS mission, their heart is set on a more distant destination, the moon, or maybe even Mars. This candid perspective came during a live press event shortly after docking. The astronaut, now settling into the station's routine of science, maintenance, and international camaraderie, described the ISS as, quote, an amazing laboratory and an engineering marvel, unquote, but also emphasized that humans' future lies beyond low Earth orbit. The sentiment is echoing a growing feeling in the space community. The ISS is an incredible achievement, but it's also a launch pad, figuratively, and perhaps one day, literally, for deeper exploration. From the vantage point of the ISS, the moon hangs as a brilliant crescent against the black, and Mars is a dim red dot in the same sky. Now, those views are a constant reminder that there's still quite the frontier to cross. While working in that microgravity, conducting experiments, and collaborating with crewmates, probably from around the world, this astronaut is already thinking about boots and regolith, the long shadows of lunar mountains, maybe the dusty sunsets of another planet. And that ambition matters. The ISS won't orbit forever. Its deorbit is planned for the early 2030s, and the astronauts of today will be the veterans leading tomorrow's voyages outward. Wanting more, well, it doesn't diminish the value of the ISS. It honors it by treating it as the training ground that is the next great leap. So while the mission's horizon is just 250 miles above the Earth, the astronaut's personal horizon is measured in hundreds of thousands, even millions of miles. And let's face it, that's exactly the kind of mindset you need when the future you're aiming for isn't just higher, it's potentially farther than maybe you've even dreamed before. Now, from a nation preparing to plant footprints in lunar dust again, or for the first time, depending on your perspective, to the people here on Earth still staring up, wondering what's next. Well, guess what? We have something for you. Yes, China is making methodical moves toward putting its own astronauts on the moon, and the latest milestone brings them one step closer. Engineers have just completed a full scale test of their new lunar lander, and it passed the two hardest parts of the job, sticking the landing and lifting off again. Now, this test took place in a specialized facility that simulates the moon's weaker gravity using suspension rigs and precision monitor motion systems. In descent mode, the lander adjusted its course using hazard avoidance sensors to dodge mark craters and borders. Maybe they should try that with the rockets and cows, and settled gently onto the simulated surface. Minutes later, the ascent stage ignited, separated from the landing platform, and climbed toward a stand in for the return spacecraft waiting in quote unquote lunar orbit. It's all part of China's plan to land humans on the moon by 2030, building on a string of robotic successes from rovers on the near and far sides to sample return missions. By proving both halves of the mission here on Earth, they're reducing the unknowns before human lives are at stake. If successful, this mission would mark the first human footsteps on the moon in over 50 years, and the first not made by Americans. Now, whether you view it as competition, cooperation potential, or just another chapter in the exploration story, one thing is for certain. The next space race is already under the way, whether you know it or not. And it looks like the moon is back on the menu, boys. And while rehearsing landings on the moons was not enough, China's eyes are still on Mars. For it is setting its sight on one of planetary science's most ambitious prizes, bringing back samples from Mars. Their plan would see a spacecraft launched to the red planet, collecting material from the surface, and return it safely to Earth. All potentially before NASA and ESA complete their own Mars sample return mission. The proposed mission builds on China's success with Tianwen-1, which put an orbiter and rover on Mars in 2021. The next step is a two-launch campaign, one spacecraft to land, gather samples, and then launch it back into Mars orbit, and another to capture that sample container and ferry it all the way back home. If it works, China could become the first nation to pull off a round trip from Mars. Now, what is less certain is whether this will be a solo effort or maybe even a shared one. International cooperation has been a backbone of major space science projects. I mean, just from the ISS to telescopes like James Webb. But geopolitical tensions have strained China's ties with NASA, and U.S. law currently bars direct bilateral cooperation. So that leaves potential partners like ESA or maybe even emerging space nations as possible collaborators. And already I agree. Red China, red planet, coincidence? I think not. Now, if China does proceed alone, the mission would still be a huge scientific achievement, returning rocks and soil that could reveal Mars' ancient climate and any traces of past life. Now, if they do find a way to collaborate, it could also be a bridge building moment in space diplomacy. Either way, the clock is now ticking. Mars launches come in roughly 26-month windows, and the sooner the mission is locked in, the sooner their samples could land in a lab here back on Earth. So with that, we're going to take a short break. And when we come back, we're heading probably, right back to the moon, because I'm sensing a bit of a theme tonight, because we do have some plans for a nuclear reactor and, some politics behind it. Then maybe from there, we'll go visit a black hole, talk about alien life on Mars and Europa, and maybe the biggest cosmic explosion since the Big Bang, and a few strange new finds you'll want to hear about. So stay with us after, we'll go with 2 minutes and 51 seconds. We will be right back.
In the quiet of the night, with my radio on, I'm searching for a sign from a world beyond. I'm picking up alien signals from a distant star, in the vast expanse of space where the unknown are. Started coming to crackles, inside just a doubt, hoping for a message from a cosmic mind. I'm picking up alien signals from a distant star, in the vast expanse of space where the unknown are. Light comes and crackles as I adjust the dial, hoping for a message from a cosmic mind. I'm picking up alien signals from a distant star, in the vast expanse of space where the unknown are. What secrets do they hold? Can you see a song? Do they know we're here at all alone? I'm picking up alien signals from a distant star, in the vast expanse of space where the unknown are. I'll keep on listening to the cosmic symphony, as long as it takes to find a friend in infinity. What secrets do they hold? Can you see a song? Do they know we're here at all alone? I'm picking up alien signals from a distant star, in the vast expanse of space where the unknown are.
And welcome back aboard. And we're going to kick off the second half of the show with a ride to the moon's southern pole, courtesy of NASA and a company that we just love her. I mean, love them. We love them here. That's what I meant. Yeah. So anyway, NASA has awarded Firefly Aerospace. Let's all take a moment. Morgan. Okay, back in focus. I'm back on focus. Yeah, NASA has awarded a $177 million contract to deliver not one, not two, but 3 rovers to the moon's south pole in 2026. The mission is part of NASA's Commercial Lunar Payload Services program, which taps private companies to carry scientific instruments and hardware to the lunar surface ahead of crewed Artemis missions. Now, Firefly's lander will target a region near the South Pole called Schrodinger's Basin, a scientifically rich area with permanently shattered craters believed to hold water ice. The three rovers will work together, one scouting terrain, one handling scientific measurements, and one carrying instruments to study the environment in real time. By coordinating, they can cover more ground in less time, increasing the science return from each lunar day. Now, this isn't just about explorations, it's a technology test bed. The rovers will be assessing how to navigate extreme lighting conditions, cope with temperature swings from blistering sunlight to deep, deep cold, and communicate effectively in terrain where line of sight to Earth is limited. The data they collect will help shape and design the future lunar habitats, power systems, and resource extraction equipment. It's also a demonstration of how commercial partnerships are really accelerating the Artemis timeline. Instead of NASA building every piece of hardware in house, companies like Firefly can, well, let's face it, move faster, take more design risk, and deliver payloads that meet NASA science goals while advancing their own engineering chops. If all goes to plan, by late 2026, three small but capable machines will be trundling across one of the moon's most famous and remote frontiers, and every sample, scan, and byte of data will help us prepare for the day astronauts will eventually walk there themselves again, or for the first time, depending on your perspective. And hey, since we're already talking about Firefly Aerospace, Morgan, they are aiming for orbit of a different kind. This one involves the stock market. The company has filed for initial public offering that could raise as much as $632 million, valuing Firefly at nearly $5.5 billion with a B dollars. It's a big move, and it comes on the heels of an even bigger one back in March, the landing of their Blue Ghost lander on the moon. Now, that touchdown wasn't just a company first, it was a historic first for any commercial lander. Blue Ghost carried NASA science instruments to the lunar surface under the Commercial Lunar Payload Service program, touched down softly, and completed its objectives without a mission ending failure. In an era where even experienced space programs sometimes, well, let's face it, lose landers, pulling off a perfect first shot is a rare achievement. Now, the IPO will put 16.2 million shares up for sale. 16.2, that's, if I'm not mistaken, that's in hands. That's actually the size of Secretariat. I don't know why I still have that in my brain. Anyway, these 16.2 million shares up for sale at an expected price between $35 and $39 each. If all goes as planned, that influx of capital will help Firefly scale up production of their Alpha rockets, develop follow on Blue Ghost landers, and expand into more lunar missions, which means maybe we'll get to see Morgan more. I count that as a win-win. Now, going public, though, does come with a different kind of risk. Investors will be buying not just in the Firefly's engineering success, but into the future of the commercial moon market itself, a market that's still more vision than revenue. Mining water ice, building habitats, and providing regular cargo runs are all on the horizon, but, well, they're not yet profitable industries. Still, Firefly's timing is smart. The Artemis program is ramping up, and the demand for reliable lunar delivery partners is, well, only going to grow rapidly. By turning public capital into hardware, Firefly can cement itself as one of the go-to companies for getting things and maybe someday people to the moon. And if their next missions go as smoothly as Blue Ghost, the company might just prove that in the new space economy, there's room for rockets, rovers, and reactors, and returns for the people bold enough to back them. And speaking of reactors, how about we go over to NASA? Because they're already thinking about how to power what comes next, not with solar panels, but something far, far more potent. NASA is accelerating plans to place a nuclear reactor on the moon by 2030, and interim administrator Sean Duffy is making sure it moves from blueprint to reality. The push isn't just about engineering, it's really strategy, survival, and making sure that when humans return to the moon for the first time to stay, they can actually keep the lights on. Now, solar power works well in Earth orbit and on Mars in certain conditions, but the moon's poles, where much of the long term exploration will focus, are, well, they're very different animals. The lunar night lasts about 14 Earth days. That means 2 straight weeks without any sunlight. And temperatures, oh, well, just randomly plunging to around a minus 280 degrees Fahrenheit. Dust can blanket solar panels, further slashing efficiency just when energy is most critical. In these conditions, they're ju- they batteries alone aren't enough. You're going to need a constant independent power source. And that's where efficient surface power comes in. NASA's target is a compact 100 kilowatt reactor capable of running continuously for at least 10 years without refueling. That's enough electricity to power a cluster of habitats, science labs, rovers, life support systems, communication gear, and even industrial equipment like water ice extraction rigs. The idea is to make a lunar base truly self sufficient, able to operate day or night, in dust storms, or during emergencies. Now, Sean Duffy has been blunt about the motivation. The U.S., whether people want to admit it or not, is in a race with China for a sustained presence on the moon. Whoever establishes reliable infrastructure first, well, they kind of get to, shape the rules of lunar exploration for decades. In his words, energy is the key to that foothold. Without it, a base, well, a base is just a camping trip. And like we talked on last episode, yes, South Korea's looking at it too. And we don't want hot South Koreans beating the Americans. I mean, not unless they have YouTube cameras and their feeds live, but you know what I mean. Now, the reactor concepts being studied are remarkably compact, small enough to fit inside a single lunar lander. One design uses uranium fuel rods surrounded by passive heat pipes. These pipes move the reactor's heat to a set of Stirling engines, which quietly convert it to electricity without any moving parts inside the reactor core. Fewer moving parts mean, well, fewer breakdowns, an absolute necessity, when you're operating 250,000 miles from the nearest repair shop. That said, this isn't just about keeping astronauts alive. Constant power really opens the door to technologies that would be impossible on a sunlight only schedule. Ice mining for rocket fuel requires power hungry drills and processing plants. Scientific experiments like particle detectors or deep space radio arrays can run without interruption. Greenhouses could grow food year round instead of in fits and starts. And even construction robots could work around through the long lunar night, building new habitats and infrastructure. Now, that said, NASA's timeline is ambitious. Testing has already begun with the small scale prototypes here on Earth, with the Department of Energy and private contractors working alongside NASA engineers. The goal is to have a flight ready unit tested and qualified for space by the end of the decade. If they succeed, the first human crews living on the moon will have a steady supply of electricity, no matter the weather, the dust, or even the angle of the sun. And I think that's the real shift here. The Apollo missions proved we could visit the moon. I know there are some out there, we didn't go. But instead of just visiting the moon, a nuclear reactor would prove we could actually live there. It really is a difference between a temporary campsite and a permanent outpost. Between a place just go and a place you can stay. That said, we have been talking about building rockets and, landing on the moon, but what if your next spacecraft didn't even carry its own fuel? What? What if it was pushed by light itself? And what if the destination of all places was all the way to a black hole? An astrophysicist has put forward a bold idea. A laser propelled mini spacecraft capable of traveling to the nearest black hole in the fraction of the time chemical rockets could manage. Now, this concept borrows from the well known solar sail idea, using light pressure to push a craft forward, but replaces sunlight with an immense focused laser beam fired from Earth or lunar orbit. Now, here's the challenge with sending anything to a black hole. They're a little bit away, just, out there a little bit. Even the closest known candidate, Sagittarius A, sits in the center of our galaxy, 26,000 light years away. But there are some smaller black holes much closer, and still there's hundreds or thousands of light years out. A conventional spacecraft, even with our fastest propulsion, would take millennia to get there. The proposed mini spacecraft would be incredibly light, perhaps no bigger than a shoebox, with a reflective sail as thin as human hair and dozens of meters across. The laser array would accelerate it to the significant fraction of light speed over the course of weeks or months, allowing it to reach a nearby stellar mass black hole within human lifetime. Now, I know, one of the questions is obvious. Why? Well, getting close to a black hole is like standing at the edge of physics itself. The craft could study the accretion disk, the jets of matter ejected, at near light speed, and the warping of space-time in real time. These are environments right now we can only model in supercomputers. A direct mission could confirm or overturn some of the most fundamental theories about gravity and quantum mechanics. Now, it won't be easy. There are some hurdles. First, building a laser powerful enough to push a probe to such speeds would require enormous infrastructure, possibly, on the moon to avoid atmospheric distortion. The sail itself would have to survive years in deep space, dodging interstellar dust at relativistic speeds. And yeah, this won't be like NASCAR. It's going to need, stay straight. Navigation will be a little bit of a bitch because course corrections get tricky when you're riding a beam of laser light. But still, the payoff is tantalizing. In a way, it's the perfect fusion of engineering, ambition, and scientific curiosity. A mission that starts at a launch pad but ends at one of the universe's strangest frontiers. And let's face it, that makes it the perfect gateway into the science side of our journey the rest of the way through. So you may have been, imagining riding that beam yourself of light to the black hole. Well, even though we've all seen that movie, thank God Disney hasn't remade it yet. But now let's reel it back toward home and ask where life might be hiding a little bit closer to our solar system and what it might be, living on it if it isn't sunlight. This next story is brought to you by the executive producer. Scientists are expanding the boundaries of what we call habitable. A new study suggests that Mars, Europa, and Enceladus, along with icy moons and even rogue planets far from any star, might sustain life using a power source that never rises or sets. Cosmic rays. Now, cosmic rays are high energy particles from deep space, born in the chaos of supernova and other violent cosmic events. On worlds with little to no atmosphere or no magnetic field to block them, these particles can penetrate several feet into the surface. When they strike water ice, they can break apart molecules, releasing electrons in a process called radiolysis. Simple microbes could use these electrons as an energy source, a potential lifeline in places where sunlight is non existent. Lead researcher Dimitra Etri and her team calculated how much biomass cosmic rays could support on 3 of the solar system's most intriguing worlds. Enceladus came out on top, enough to support a thin but persistent layer of microbial life beneath the surface ice. Mars ranked second, where such life might hide in permafrost just below the surface. And Europa, Jupiter's cracked, streaked ocean moon, was third. But even here, cosmic rays could power life in the shallow pockets of salty liquid water close to the surface, maybe even closer than we once thought. And yes, Ordia has taught me this word very well. Now, the team has given this zone, of course, a name, The radiolic habitable zone, the sweet spot below a world's surface where cosmic rays deliver enough energy to support life without overwhelming it with radiation damage. It's a definition that works regardless of how close a world is to the star. It could apply equally to Pluto, the planet, or maybe even a rogue planet drifting between stars. Now, this, of course, doesn't mean cosmic rays are the only possible power source for alien life. You do have hydrothermal vents, leftover volcanic heat, and even faint traces of sunlight might contribute in some environments. But radiolysis is a new durable pathway, one that might keep ecosystems alive for billions of years on worlds, well, maybe we've been overlooking. In short, the habitable zone just got maybe a little bit bigger, a little bit stranger, and I think much more exciting. And some of the best places to find life may be cold, dark corners of our cosmic backyard. So let's swing hard into a different direction here. To something so bright, so violent, it makes most of the universe look like it's on a dimmer switch. Now, Zaphod Beeblebrox once said the best bang since the big one was, of course, the triple-breasted horror of Eroticon 6. But out here in our known universe, the title might belong to a cosmic explosion so enormous, it's been nicknamed the Boat, the brightest of all time. Officially, it's GRB 221009A, which is a gamma ray burst, the most energetic kind of stellar death in the cosmos. These events happen when a massive star's core collapses into a black hole, releasing titanic jets of energy that blast outwards at nearly the speed of light. Most gamma ray bursts last only seconds. Yeah, rub it in. And their afterglows fade quickly. But the Boat was different. It erupted 2.4 billion with a B light years away, slammed into our detectors with such ferocity that it briefly blinded some of them. And it's been glowing ever since. Now, for astronomers, this is like winning the cosmic lottery. The burst's unusual proximity, by gamma ray standards, combined with its staggering intensity, meant we could study it in exquisite detail across the entire electromagnetic spectrum, from radio waves to the highest energy gamma photons ever recorded from such an event. And the scary thing is, it's still not done teaching us. The afterglow has revealed jets that are narrower and more finely structured than models predicted, suggesting magnetic fields may play a bigger role in shaping these explosions than previously thought. The high energy photons that have continued arriving years later are pushing the limits of our theories about particle acceleration, take that CERN, and the physics of shock fronts. Now, these explosions aren't just spectacular, they're cosmic alchemists. The extreme conditions inside them forge heavy elements, gold, platinum, uranium, and spew them across their host galaxies, seeding future generations of stars and planets. In a sense, the metal in your wedding ring, if you're married, may have once been a part of a gamma ray burst shrapnel. Kind of disgusting if you think about it in a way. Anyway, for scientists, the Boat is a gift that keeps giving, letting us piece together a story that begins in the death throes of a star and ends in the chemical enrichment of the universe. While Eccentrica may hold her crown in certain circles, but when it comes to cosmic scale fireworks, the Boat makes a very strong case for second place. And, well, unlike Zaphod's favorite, this one comes with hard data and not just a reputation to withhold. And somewhere, just somewhere, I can picture board prefect taking notes on the entry for gamma ray burst, and it having right after it, avoid standing directly in front of one. And yes, from hitchhikers to the aforementioned CERN's Large Hadron Collider. Well, physicists have taken another step toward answering a question so fundamental it's almost unsettling. Why does anything exist? According to our best understandings of physics, the Big Bang should have created matter and antimatter in equal amounts. Now, this symmetry, of course, sounds elegant, but there's a catch. If matter and antimatter are perfect mirror twins, they annihilate each other on contact. Equal amounts would mean nothing but radiation left behind. No stars, no planets, no us. Yet we live in a universe made almost entirely of matter. Antimatter exists, but it's fleeting, rare, and usually made artificially in labs so we can study it. This mismatch, the fact that matter somehow won, is one of the greatest mysteries in cosmology. The new CERN, hashtag CERN is innocent, results focus on particles called B mesons. These short-lived particles made of a bottom quark bound to another quark are created in high-energy collisions inside the LHC. Alongside them, the same collisions produce their antimatter counterparts, anti-B mesons. Now, in a perfectly symmetrical universe, the decay of B mesons and anti-B mesons into later particles would be identical. But that's not what CERN detectors saw. Instead, the decay shows a subtle but persistent difference, a violation of the combined symmetry known as CP for charge and parity. Charge refers to swapping particles with these antiparticles. Parity refers to flipping their spatial coordinates like a mirror image. If CP symmetry held perfectly, matter and antimatter would behave the same way in decay. The fact that they don't means there's a built-in bias in the laws of physics. One that in the early universe could have tipped the scales toward matter. Now, this isn't the first time CP violation has been observed. Hints have shown up in kaons and other mesons before, but each new measurement is sharpening that picture. The imbalance CERN has found is small, far too small to explain the entire matter-antimatter asymmetry by itself. So that means there must be other processes, perhaps involving undiscovered particles or interactions that contributed to the early bias. Now, the stakes here are cosmic. If the universe had been perfectly symmetrical, every proton would have been matched with an antiproton, every electron with a positron, and all of it would have vanished in mutual annihilation. There'd be no galaxies, no chemistry, no biology. The only way to win would be not to play, and that seems to be what they are doing. The fact that the scales tipped ever so slightly toward matter billions of years ago is the reason you're hearing this sentence now. And yes, I just dropped a War Games reference in the middle of a physics lessons. I've come such a long way on this program. Now, the work at CERN isn't just about confirming the standard model, it's about probing its limits. Further experiments, perhaps at even higher energies or the next generation detectors, could reveal new sources of CP violations that, well, will complete the entire story. Every collision in the LHC is a bit of the roll of the cosmic dice, looking for the rare throws that don't match the script. And yes, that is a tease to a certain show coming back soon. Now, for now, we know this. Somewhere in the universe's earliest moments, nature broke the rules just enough to let matter win. And from that tiny imbalance came everything. Stars, planets, oceans, clouds, and even those curious primates who traded leaves for monetary gain. But one day, those primates would build machines to figure out how it all began and why it was such a mistake. Oh, well, friends, let's lace up your moon boots because the sky over the next 2 weeks has more action than maybe even a Douglas Adams pub crawl. We begin with our old travel companion, the moon, now in its waning gibbous phase as we open the week. By August 19th at 2:26 a.m. Eastern, She'll be a delicate waning crescent, only 40% lit. Like half my audience, probably. Perfect for stargazing before the dawn. The new moon arrives August 24th at 5:16 a.m., cloaking the night in darkness so deep even the Milky Way will seem brighter than usual. And yes, we just passed the full sturgeon moon on August 9th. The Anishinaabe people, well, they called it the Manun Mehikya Gisis, or the rising moon, marking the season when wild rice is gathered from the lakes, a reminder that even the heavens keep time with the turning of the earth. Now, if you're up late, Saturn will rise in the southeast around 9 p.m. A nice creamy yellow jewel just past opposition, bright enough to see even with modest binoculars. But if you got a telescope, those famous rings are tilted nicely right now, giving them that mini cosmic frisbee look that we all love about Saturn. Jupiter follows close behind, rising just before midnight in the east, big and bold. Its four largest moons, Io, Europa, Ganymede, and Callisto, will line up in different configurations every night, like cosmic beads on a string. Mars, well, Mars is still hugging the morning horizon in the east, faint but red, if you catch it in an hour before sunrise. Think of it as a shy dinner guest who shows up just before you do the dishes. We all know how guests are. And the Perseid meteor shower peaked just before our forecast window, but let's face it, stragglers are still streaking through the night. And with the moon dimming toward new, you'll actually have a solid chance to catch a few fiery trails in the northeast after midnight. And overhead, the summer triangle made of Vega, Deneb, and Altair commands the night sky. Looking straight up, find the bright bluish star Vega, and you're started your tour of one of summer's most iconic constellations. And final thought. So whether you're looking for Saturn's rings, chasing the last of the Perseids, or just leaning back and, to watch the slow dance of the summer triangle, remember, the best seat in the universe is the one you take the time to sit in. So that's it for tonight's show. Thank you for tuning in, when and however and why ever you do. Special thanks to NASA, SpaceX, Space.com, Ars Technica, NASA Spaceflight, Popular Mechanics, and more for the stories and inspiration tonight. With me at the helm, the EP setting course, and the ship's computer in the back, whispering star maps through the static. This is The Lost Wanderer. Until next orbit, I hope you enjoyed this show, learned a little bit along the way, and maybe had a laugh or two as well.
The universe is a pretty big place. It's bigger than anything anyone has ever dreamed of before. So if it's just us, it seems like an awful waste of space. Right?
When I was young, it seemed that life was so wonderful.